Hey guys, Mr. Klein here, and here we are with our last lesson of the chapter on changes in state of matter. Now we're going to look over this in class a lot more, and so this is more of a general statement about what this stuff is. So let's go ahead and let's get started with this by talking about changes in states of matter. Now, in the last lesson, we talked about solids, liquids, and gases, and in many ways it seemed rather simple. We kind of know that. And specific changes in matter, we kind of know that too. After all, we know what happens when liquid water gets cold. It turns to a solid. When it gets too hot, it turns into a gas. But we have some specific terms that we use, and even though we generally know them, it's a good way to review over it just to make sure we understand. In order to change a solid to a liquid, you need to increase the thermal energy of the substance. In other words, you need to heat it. And the process by which we take a solid and turn it into a liquid is what we call melting. Yes, we know melting is a really important and difficult term. And for our examples, what we're going to use in class, we're going to use water. And so here's an example of frozen water over time melting. Okay, what happens right here is the solid warms up, it gains thermal energy, and it slowly turns into a liquid. So what happens? Well, first off, it reaches the melting point, and that is the specific temperature that crystalline solids will melt at. If you remember this temperature scale from the last lesson, this talks about the cooling and how solids freeze, but we can look at an opposite direction to talk about melting rather. So let's start right here. We have an amorphous solid. Okay, let's use butter. Okay, it's nice and cool. It was in the refrigerator. You kind of got to cut it hard with a knife in order to cut it. But if we leave it out over time, the temperature will go up, and the ability to cut it and shape it will become much easier until it's completely a liquid. Crystalline solids, on the other hand, have a specific temperature in which they change their state of matter. Water, of course, is a crystalline solid, and ice. So what will happen as it warms up, as we go up on the Celsius scale, we'll get to 0. This is 0 degrees Celsius. And the ice in this picture right now, right here, is all at 0 degrees Celsius until right now, at that last point of the picture. Why? Because there's a little bit that's still a solid. So as long as there is a crystalline solid that's still in its solid form, it will keep its temperature. Of course, of water is 0 degrees Celsius. So we'll have frozen water. It'll warm up to 0 degrees. It'll melt. It'll turn to a liquid, and once it's all a liquid, then it will continue to warm. And that melting point right here is 0 degrees Celsius. Melting points are a physical property of substances, so we can compare melting points to identify an unknown material. It makes it easy for us to bracket between known substances, and it helps us figure out what they are. Now, like I said right there, at the chemical level, at the molecular level, the particles of a solid vibrate, and they start vibrating faster because they have more thermal energy, and they start vibrating so much they break out of their fixed positions, and that allows it to become a liquid. And of course, the opposite of melting is freezing, or the change in state from a liquid to a solid. And freezing occurs when the particles in a liquid slow down enough that they take on a fixed position. In other words, it's the opposite of this. They start vibrating slower, that they start moving into the fixed positions and they stay there. And especially for a crystalline solid, temperature does not drop below the freezing point until the freezing is complete. Okay? So if we go back to this, an amorphous solid just gets solid, and it continues to stay solid as the temperature goes down. However, a crystalline solid will be a liquid until it gets to this point, and it'll stay a liquid. It'll stay at this temperature until all of it has solidified into a solid, and then it'll start cooling off again. Now, sometimes we can drop the freezing point, and this is what we call supercooling. So this is some supercooled water. As you can see, everything else is frozen around it. And if we disturb it, it'll instantly turn into a solid. You saw that? And as we lift it up, it crystallizes because it's getting to the point where it needed to be. So that is changing from a solid to a liquid and back to a solid. So What happens when liquids change? Okay, they freeze whenever they become a solid, but what happens when they turn to a gas? Well, the change in state from a liquid to a gas is what we call vaporization. And vaporization occurs when the particles in a liquid gain enough energy to move independently. They're not closely packed together. If you remember, gases don't have volume or shape. So what happens is the liquid's particles start vibrating so much they start bouncing off and flying independently of each other. They lose their close formation. And there's two types of vaporization that we know about. The first one is what we call evaporation. And that's when vaporization takes place only on the surface of a liquid. A good example of that is a shrinking puddle. Now, we all know puddles, like it rains. And we know that the boiling point of water is 100 degrees Celsius. But why does the ground dry up after a rainfall even though it isn't at the boiling point? Well, what happens is on the surface, the molecules get warmed up because they are moving around. And eventually they break free of each other and they start floating around as water vapor. And the surface continually loses atoms and molecules of water over time, and that causes the vaporization. And sooner or later, the puddle will shrink smaller and smaller and smaller. Next thing you know, it's completely gone. Okay, the other type of vaporization is what we think of most when a liquid turns to a gas, and that's boiling. And boiling is when vaporization takes place both above and below the surface. It takes place all over the liquid. And the temperature at which a liquid boils is what we call the boiling point. And the boiling point is the temperature where the molecules start vibrating so much that they end up breaking away. And so boiling is like, for example, we pour a pot of water and we heat it up. It gets up to 100 degrees Celsius. The molecules start bubbling up and we see a lot of steam and stuff like that. And that's when it turns to a gas. Now, just like solids, crystalline solids, water operates on the same idea in that it warms up, it gets to the boiling point, it stays at 100 degrees Celsius, and then it continues warming up from there once it's completely a gas. Okay, so keep that in mind with liquids, is that it'll get up to its boiling point, it'll stay there, and then it'll start raising temperature once it's all vaporized. Now, the reverse of vaporization, of course, is condensation. That's with the change in state from a gas to a liquid. Condensation only occurs when particles in a gas lose enough thermal energy to form a liquid. And of course, an example of that is if you have a drink and you leave it out, a cold drink, and what happens is the water vapor cools down when it reaches the surface of the bottle or cup or whatnot, and it forms those water droplets. Dew is another example of that. That's where the water vapor slows down enough that they start getting in close formation that forms a liquid. So, when we have a liquid, it turns to a solid in freezing. It turns to a gas when it vaporizes. And a gas cools down through condensation. But can matter skip states? Yes, it can. For example, particles in a solid sometimes can gain enough energy to form a gas without forming a liquid, and that's what we call sublimation. Now, where we're at in Louisiana, it almost never snows, so we don't see this. So for people up north, you know that, is that when it snows, you can have like a foot of snow, and next thing you know, you've lost a couple inches of snow. And that's because the thermal energy from the sun warms up the surface enough of the snow for those water molecules that jump off and go directly into water vapor. And so what happens is during sublimation, the particles don't pass through the liquid state as they form a gas. What essentially happens is they warm up so quickly. And the most common example, and this is an example we're going to look at in class, is through solid carbon dioxide or dry ice. Okay, it's not ice, just to be clear. Dry ice is not ice. It's not frozen water. Rather, instead, it's frozen carbon dioxide. And so what will happen with dry ice is it forms this smoke, and that smoke is actually carbon dioxide sublimating. It jumps directly from a solid to a gas because it's warming up. Dry ice is kept at the temperature in which it's frozen, and we can have liquid carbon dioxide, by the way, but dry ice is so cold is that it just warms up and so fast when it's exposed to the temperature on the surface, it just immediately jumps to the state of gas, and it completely bypasses liquids. So, to sum up this lesson, we talk about state of matter changes. The shifting between solids and liquids, whenever a solid turns to a liquid that's melting. when we turn from a liquid to a solid, that's freezing. When we have a liquid turning to a gas and back, that's what we call vaporization. There's two types of vaporization. Evaporation is when the surface of a liquid turns to a gas, whereas boiling is when all throughout the liquid it turns to a gas. And the opposite of all that, when a gas slows down and condenses into a liquid, that's what we call condensation. Sometimes particles of solids can warm up so quickly or be exposed to temperatures that's far above its melting point that it just completely jumps to a gas, and that's what we call sublimation. So that's our lesson. That's the end of the chapter. And so if you have any questions, please let me know, and thanks for watching.